Today we're going to graph systems of inequalities. A system of inequalities is two or more inequalities that we're going to graph on the same coordinate plane, so the same xy axis, and then we're going to shade, and the regions that are shaded is the solution. All right, so let's try our first example. In order to graph these, the first thing I want to do is put them in slope-intercept form. And the reason I want to do that is so that I can find the y-intercept and then the slope so that I can graph. So here with my first equation, I'm going to subtract the 2x to the other side, which gives me negative y greater than negative 2x plus 1, divide by negative 1. And when we do that, remember that your symbol switches from greater than to less than. The two negatives go positive, and then minus 1. So my y-intercept is negative 1. That's where I'm going to start my line. And then my slope is 2 over 1. That means after I plot this first point, I will go up 2 and to the right 1 space to plot the second point. So let's do our first line, starting at negative 1. From that point, I follow my slope. It's like directions to get to the next point. I go up 2 and to the right 1. Up 2 and right 1. I'm going to go ahead and fill my whole graph in. You can also go down and to the left. Because it's less than, it's going to be a dashed line. And I'm not going to shade the line just yet, but I'm going to indicate, because it's less than, it points to the y. That means y needs to be smaller. So I'm going to shade below the line. Before I shade though, I want to go ahead and graph the second line. X plus y greater than or equal to 3. Subtract the x, let's put it in slope-intercept form. Y is greater than or equal to negative x plus 3. Your y-intercept is 3, and then your slope is negative 1 over 1. Plot your first point, and then the slope, which is the directions to get to the second point, tells me to go down 1 and to the right. The negative tells me to go down, and then the bottom number is positive, so I go to the right. I could also go up and to the left. This one is a solid line because it's equal to. So I'm going to try to draw that in. And this one is greater than. It opens up to the y, which means y is the biggest number, and I'm going to shade above. So I find it easier to graph these using different colors. Now I can say that I want to shade above the green line and below the blue line. Coming to my graph, I need to stay above the green line, but I don't start shading until I'm below the blue line. And that is the solution to the system of inequalities. Any point within this shaded region is a solution. Great. Now you try this one. Put each of your lines into slope-intercept form, then graph them, and push pause while you do your work. Resume play when you're ready to check your answer. All right, this is what my two lines look like. Putting the first equation in slope-intercept, I just subtracted the x over. So my y-intercept was at positive 5, and my slope was negative 1 over 1. So I started at 5 and I went down 1 and to the right, down and to the right. With my green line, subtract the 2x over and then divide by 3. That gave me a y-intercept also of plus 5. And this time my slope was negative 2 over 3. So starting at 5, I went down 2 and to the right 3 to graph my next line. I also went up and to the left. Now I need to decide how I'm going to shade. The blue equation says y is greater than. That means I need to shade above. The green line says y is less than. It points to the y, so y is smaller, and that means I need to shade below. So I'm above the blue line and below the green line. Above blue, below green. That gives me this little segment right there. Great, let's try graphing some absolute value equations. In this example, I've got the first equation, which is a line, and the second equation, which is an absolute value. And as a reminder, the absolute value forms a V for value, absolute value. So one of my graphs is a line, and the other graph is going to be in the shape of a V. So let's do our first graph. It's already in slope-intercept. So positive 1 is my y-intercept. And I have a slope of negative 1/3. That means I'm going to go down 1 and to the right 3. I'm attaching the negative sign to the 1, and that makes the 3 positive. You could also have the 1 be positive and the 3 be negative, making you go up 1 and to the right or to the left 3 spaces. And this is going to be a dashed line. The next one, the absolute value, I need to decide on my vertex. Your vertex for the x value is the opposite of what's inside. So instead of negative 1, will be positive. And there's no y value on the outside. So my vertex is positive 1, 0. This negative sign indicates my slope. So instead of pointing up, it's going to point down. I go down 1 and to the left, down 1 and to the right. It's greater than, so it's going to be dashed. And now we need to decide on the shading. With my line, y was less than. It points to the y, which is smaller, and that means I need to shade below. The absolute value, it shows that y is greater than. It opens to the y, which means it's greater, so I shade above. So I need to be below the line and above the V. That's going to be this section outside the absolute value, but stay below the line. All right, let's give you a chance to try one. Here is your two sets of equations, absolute value on the top, a line on the bottom. Go ahead and graph each one, push pause while you do the work, and then resume play to check your answer. Here's the graph of my two equations. The red equation was the absolute value, so I first identified the vertex. The x value is the opposite of what's inside, and the y value is the same as the out. So I went left 3 and up 1. There was no negative sign, so that indicates it points up, and it's dashed. And then the blue is my line. My y-intercept was -5. I couldn't really go down 1 and to the right, so this time I went up and to the left. Up and to the left. So with my absolute value, it points to the y. We need to shade below. And the line, the y is greater than, so you shade above. I'm below the v and above the line. Great, so that's graphing a system of inequalities. And let's try one last problem as a word problem. We all love word problems, don't want to leave that out. A pizza parlor charges $1 for vegetable toppings. Let's call that our x value. And $2 for meat toppings. Let's call that our y. So down here on the x-axis, I'll put veggies. And on the y-axis is the meat. You want at least 5 toppings on your pizza. That means I need 5, 6, 7, 8, more than 5 toppings. So at least will be written as veggies plus meat need to be greater than or equal to 5. 5 is the smallest amount of toppings. You have $10 to spend on toppings. That's the money in your pocket. You can't spend $12. You could spend 8, 9, or 10. So I attach my dollar value, 1x plus 2y, so I'm attaching the value to the meat and veggies, has to be smaller than or equal to $10. These are my system of equations that defines the constraints associated with buying the pizza. Go ahead and put each in slope-intercept form and graph the two lines. All right, here's the graph of my two lines. For the red one, I just subtracted the x across, started at 5, and had a negative slope. For the blue equation, I subtracted the x, and then I had to divide by 2y, which made my slope -1/2 x plus 5. Because this is an actual word problem, I'm going to talk a little bit about my solution. I need to stay below the blue and above the red line. However, I'm talking about toppings on a pizza. I can't really have half a topping. So when I do my shading, I'm going to stay on the whole numbered sections. I could have 5, 4, right here. I can stay within the region. So any of these whole numbers within my region represents a solution. And that is graphing inequalities, systems where there's 2 lines, absolute value, and the word problem. Thanks for listening.